In this problem, we've been given a table of derivative values f prime of x, and we've been asked to give a full description of the function f of x. First, we're going to start by noting a few important little facts that we know about derivative functions and its relationship to the function f of x. Recall, f prime negative means that the slopes of f are negative, meaning f would be decreasing. And we know that if f prime is positive, then we know that the slopes of f are positive, meaning f is increasing. Furthermore, we learned about concavity. We learned if f prime is increasing, then that tells us that f is concave up. We know if f prime is decreasing, then we know f is concave down. When we're done here, we're going to have a nice full description of the function f, where it's increasing, decreasing, concave up, concave down. It's important when we're writing our descriptions that we never, ever use the word it. We're always talking about the function f prime and its behavior, the function f and its behavior. Don't ever say it is increasing, it is decreasing. We need to know what function are you talking about. My recommendation to help you organize your thoughts is to create 2 more columns added onto this table. I'm going to add a column directly to the right here that tells us the sign of f prime and increasing or decreasing f prime. Notice I'm not just saying sign, increasing, decreasing. I'm saying sign of f prime, increasing or decreasing f prime. I'm going to make a nice area here for me to write my descriptions. And then in my column to the farthest right side, I'm going to write a description about f. F increasing, decreasing. And also f concave up or down. All right, now I'm going to go look at the actual values in my table of f prime values, and I'm going to note intervals of distinct behavior. The first interval of distinct behavior is the f prime values from -4, -1 to 0. Now I call this a distinct set of behavior because on this entire interval, f prime is negative. Now notice I extended that interval all the way up to where f prime is 0. Notice if you were to have the values in between here, between f prime -1 and f prime 0, they would be things like -0.9, -0.5, -1, those values between -1 and 0. So you would expect that the f prime values would be negative all the way up till the point where f prime became 0. So f prime is negative here. Also note that it starts at an f prime value of -4, then becomes -1, then goes up to 0. They start very, very low and get higher and higher until they reach 0. That means the f prime values are increasing. They're getting bigger. They're -4, then -1, then 0. Those values are increasing. So note what that now tells us about f. F prime is negative, so f is decreasing. F prime is increasing, so f is concave up. All right, the next interval of behavior, the f prime value is 0, then 1, then 3, then 5, then 7. So those are all positive values, and they're getting bigger and bigger, all the way from f prime equals 0 up to f prime equals 7. So on that interval, f prime is positive, and also f prime is increasing. Since f prime is positive, the slopes of f are positive. That means f is increasing. Since f prime is increasing, that means f is concave up. So on this interval, where the f primes go from 0 to 7, the f of x function is increasing concave up. Then another change occurs in our f prime values. The f prime value is starting at 7, and then it's 5, then 4, then 1, then 0. Those f prime values are still positive, but you see that they're getting smaller and smaller, 7, 5, 4, 1, 0. So the f primes are positive, but the f primes are decreasing. F prime positive. Slopes of f are positive. So f is increasing. F prime is decreasing. So that means f is concave down. So on that interval, the function f is both increasing and concave down. The last interval of behavior that we see in the table, our f prime values are 0, then -1, then -3. So on this interval, f prime is negative, and we also see that these numbers are getting smaller and smaller, -1, -3. So the f primes are decreasing. F prime is negative. The slopes of f are negative, so f is decreasing. And f prime is decreasing, so f is concave down. My last step here will be to describe the actual x values that produce these intervals of behavior. So from the table given here, we see the first interval spans from -3 up to -1 for the x's. The next interval spans from -1 up to 3 for the x's. Then the interval is from 3 up to 7, and then from 7 up to 9. And I'll just add in some conclusion sentences at the bottom. So in conclusion here, the first interval is -3 to -1. So I say, on the interval -3 less than x less than -1, the function f of x is decreasing concave up, because the function f prime is negative and increasing on that interval. Notice how I am describing this. On this interval, the function f is doing this because the function f prime is doing this. For the next interval, on the interval from -1 to 3, the function f of x is increasing concave down, up because the function f prime of x is positive and increasing. On the interval 3 to 7, the function f is increasing concave down because the function f prime is positive and decreasing. And lastly, on the interval 7 to 9, the function f is decreasing concave down because the function f prime is negative and decreasing on that interval. We could take these 4 intervals of behavior and we could actually sketch a little graph of the function f of x using our description. Notice that we do not know how high or low the function f of x starts, but we do know that if we have x equals -3 as our starting place, from x equals -3 up to x equals -1, our function f of x should be decreasing concave up. So it looks like this. Then from -1 up to 3, the function f of x changes to becoming increasing concave up. So like so. Then from 3 to 7, the function f of x is increasing concave down. Then from x equals 7 to 9, the function f of x is decreasing concave down. So our function f of x roughly looks like this.